I'm AmelieJuhin. I'm a French research scientist at the CNRS. I work at the Institute of Mineralogy, Physics of Condensed Matter and Cosmology in Paris. And I'm very honored, very pleased to be awarded the Young Scientist Award this year. So I wanted to be a science teacher, so I was admitted at the École Normale Supérieure and studied physical chemistry. So I even took the agrégation, which is an examination to become a teacher, but then I started doubting. I started a PhD thesis in Paris and came to the ESRF for experiments. That was the trigger. Then it became obvious that I would be a scientist, and I chose X-ray spectroscopy because this is a very diverse field. I can do calculations, I can do experiments, and to me this research is very fruitful, stimulating. After my PhD thesis, I went for a 2-year postdoc in Utrecht University, and then I came back as a CNRS researcher in Paris. In 2015, I was awarded the Young Scientist Award of the International X-ray Absorption Society, and last year I was awarded the Bronze Medal of the CNRS. So I'm a spectroscopist, so I do X-ray spectroscopies, core-level spectroscopies that probe empty levels of an absorbing atom. And what I aim for is to go beyond the average isotropic picture that is provided by powder samples. So I study on purpose samples that are orientated either because they are single crystals or because they are orientated by a magnetic field. And I study their dichroism, which is the dependence of the spectrum on the polarization of the incident beam. This is related to electronic and magnetic structure of this absorbing atom, but this is not straightforward to interpret. So I've always used feedback from theoretical calculations to interpret the experimental data, which, depending on the case, can be monoelectronic approaches or many-body approaches. So I've been a user of the ESRF for more than 10 years. I started on the French CRG beamline doing Zanes and exhaust measurements. Then I became a regular user of ID26 beamline, the hard X-ray RIGS beamline, and then a regular user of ID12, the hard X-ray XMCD beamline. So these dichroic signatures that I'm looking for are not straightforward to measure, although they are connected to properties that are macroscopic, such as color or magnetism. This requires very good experimental conditions to be measured, such as high resolution, extremely good signal-to-noise ratio, and beam stability. So I obviously benefited a lot from the expertise that had been developed at the ESRF. For example, the 17 Tesla magnet on ID12 is very unique, but it was also through a close collaboration with the beamlines, especially with ID26 beamline, that we managed to measure dichroic effects that had not been measured before, or develop experiments that was not existing before. The combination of RIGS with a hard X-ray XMCD is a novel spectroscopy, so it brings in new information and also new questions. And we've shown that it's complementary to the existing magnetic spectroscopies, XMCD at the K edges and at the L23 edges. So I think it will bring people from the magnetism community, but also outside this community, for example Earth science, to use these techniques to solve questions related to their materials. Also, the field of bimagnetic core shell nanoparticles will benefit, I think, a lot from the technique because it allows disentangling the contribution of the core and the contribution of the shell to the magnetic properties. And finally, the fields of magnetic colloids and ferrofluids will benefit from the technique because it allows measuring these systems as liquids and as frozen liquids. I'm currently very interested in biomaterials whose magnetic properties can be switched by application of pressure, and also by magnetic liquids and colloids whose magnetic properties can be varied by application of several parameters. So in that context, I'm very enthusiastic about the upgrade of the ESRF because the expected gain in resolution and brilliance is offering a very nice prospect to measure this dichroism in even better conditions.